The diazonium salts have the general formula Rn2 plus X minus, where R stands for an aryl group and X ion may be Cl minus, Br minus, HSO4 minus, F4 minus, etc. They are named by suffixing diazonium to the name of the parent hydrocarbon form, which they are formed, followed by the name of an ion such as chloride, hydrogen sulfide, etc. The N2 group is called diazonium group. For example, C6H5N2 plus HSO4 minus is called benzene diazonium hydrogen sulfate. Primary aromatic amines form arene diazonium salts which are stable for a short time in solution at low temperatures 273 to 278 Kelvin. The stability of arene diazonium ion is explained on the basis of resonance. The following structures in which it exists is given below. Method of preparation of diazonium salts. Benzene diazonium chloride is prepared by reaction of aniline with nitrous acid at 273 to 278 Kelvin. Nitrous acid is produced in the reaction mixture by the reaction of sodium nitrite with hydrochloric acid. The conversion of primary aromatic amines into diazonium salts is known as diazotization. Due to its instability, the diazonium salt is not generally stored and is used immediately after preparation. C6H5NH2 plus NaNO2 plus 2HCl reacts at 273 to 278 Kelvin to give C6H5N2 plus Cl minus plus NaCl plus 2H2O. Physical properties. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold but reacts with water when warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is a water insoluble and stable at room temperature. The reactions of diazonium salts can be broadly divided into two categories: reactions involving displacement of nitrogen, reactions involving retention of diazo group, coupling reactions. Click on the buttons to know more. Reactions involving displacement of nitrogen. Diazonium group, being a very good leaving group, is substituted by other groups such as Cl, Br, I, Cn and OH, which displace nitrogen from the aromatic ring. The nitrogen formed escapes from the reaction mixture as a gas. Replacement by halide or cyanide ion. The Cl, Br and Cn nucleophiles can easily be introduced in the benzene ring in the presence of Cu1 ion. This reaction is called Sandmeyer reaction. Arn2 plus X minus forms ArCl, Arbr and ArCn in the presence of reagent CuCl, HCl, CuBr, HBr and CuCN, HCN respectively. Also in the reactions, N2 is released. Alternatively, chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. This is referred as Gattermann reaction. ArCl and ArBr are formed in the presence of CuHCl and CuHBr. Also, N2 and CuX are released in each reaction. The yield in Sandmeyer reaction is found to be better than Gattermann reaction. Replacement by iodide ion. Iodine is not easily introduced into the benzene ring directly, but when the diazonium salt solution is treated with potassium iodide, iodobenzene is formed. The following reaction is given below. Replacement by fluoride ion. When arene diazonium chloride is treated with fluoroboric acid, arene diazonium fluoroborate is precipitated, which on heating decomposes to yield aryl fluoride. The following reaction is given below. Replacement by H. Certain mild reducing agents like hypophosphorus acid, phosphinic acid, or ethanol reduce diazonium salts to arenes and themselves get oxidized to phosphorus acid and ethanol respectively. The following reaction is given. Replacement by hydroxyl group. If the temperature of the diazonium salt solution is allowed to raise up to 283 Kelvin, the salt gets hydrolyzed to phenol. The reaction is given below. Replacement by NO2 group. When diazonium fluoroborate is heated with aqueous sodium nitrite solution in the presence of copper, the diazonium group is replaced by NO2 group. The reaction is given below. Involving retention of diazo group coupling reactions. The azo products obtained have an extended conjugate system having both the aromatic rings joined through the N double bond N. These compounds are often colored and are used as dyes. Benzene diazonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with the diazonium salt to form p-hydroxyazobenzene. This type of reaction is known as coupling reaction. Similarly, the reaction of diazonium salt with aniline yields p-aminoazobenzene. This is an example of electrophilic substitution reaction. Both the above reactions are given below. From the reactions involving retention of diazo group coupling reactions, it is clear that the diazonium salts are very good intermediates for the introduction of FCl, Br, I, Cn, OH, NO2 groups into the aromatic ring. Aryl fluorides and iodides cannot be prepared by direct halogenation. The cyano group cannot be introduced by nucleophilic substitution of chlorine in chlorobenzene, but cyanobenzene can be easily obtained from diazonium salt. Thus, The replacement of diazo group by other groups is helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in benzene or substituted benzene.